Good morning, everyone. Today I will explain how a real world system we all see daily, like the traffic management at busy intersections, can help us understand an important concept in advanced machine learning called reinforcement learning. This analogy will make the machine learning concept easier to grasp. So, introduction. Traffic signals are crucial for safety and efficiency and efficiently managing the flow of vehicles where the multiple roads intersect. Reinforcement learning, a branch of machine learning, involves an agent learning to make optimal decisions by interacting with its environment. Think of the traffic signal system as an agent that learns the best way to control traffic. Lights to keep traffic lights to keep things moving smoothly. Okay, so scenario setup, traffic signal control. Imagine an intersection where vehicles come from different directions. The traffic light controller has to decide which direction gets the green light and for how long. To minimize the waiting and avoid congestion, this decision making is dynamic and depends on the current traffic situation. This process is quite similar to how the reinforcement learning agent works. Reinforcement learning basics. In reinforcement learning, we have a few key concepts: the agent, which makes decisions, the environment, which is everything around the agent, the states representing the current situation, the actions, which are the choices the agent makes, and the rewards, which are the feedback signals telling the agent how well it is doing. The agent's goal is to learn a policy that is a method for choosing actions that maximizes its total reward over the time. Mapping traffic signal to real life concepts. In traffic signal analogy, the state is the current traffic condition at the intersection. For example, how many cars are waiting on each road and for how long. This helps the traffic controller decide what to do next. Actions in traffic control. The actions are the decisions controller makes, such as switching the green light from the north-south road and to the east-west road, or deciding how long to keep the light green. These actions directly affect traffic flow and waiting times. Rewards in traffic signal. The reward tells the controller how good or bad the decision was. For instance, a reward might be higher when the cars moves without delay, and lower when the congestion or long waits. The goal of the traffic controller, like any like any RL agent, is to maximize this reward by improving traffic flow. The learning process. Here's how the learning process happens. The traffic controller looks at the current traffic, the state, which makes decision and action, then observes the result, like how well traffic moves, or the reward. Over time, by doing this repeatedly, it learns which decisions helps traffic flow the best. This trial and error learning process is exactly how reinforcement learning works. So, example application. In practice, researchers have successfully used deep reinforcement learning to control traffic lights in real cities. These systems have reduced waiting times and traffic jams by continuously learning and adjusting the signal timings based on the traffic they observe. So this is the summary mapping concepts. So let's look at this table. The traffic conditions correspond to environment state. The signal changes are the actions taken by the RL agent. The improvements in the flow represent rewards, and the strategy controller learns the RL policy. This analogy ties all the RL concepts to something tangible and familiar. So the conclusion is managing traffic signal efficiently is a real world example of how reinforcement learning works. This analogy not only makes RL easier to understand but also shows its powerful applications in everyday life. Thank you.